So now we shift gears to quadratic equations. So they want us to graph this and find the vertex and axis of symmetry. So let's first off just graph it by plotting points, just to remind ourselves that whenever in doubt, we can always do that. So let's make a little table, x, y. So first off, just when x equals 0, because that's easy, we see that y equals 5. So we'll start with that point there. And then let's go when x equals 1. Okay, it gets really big, right? Because it's 2 plus 8 plus 5, so it's 15. Ooh, well, first off, let's correct that point. That should be there. So 5. Let's delete this for a second. Oh, I need the equation, though. What's the equation? 2x squared plus 8x plus 5. So let's delete that so we can go up 5, 5, 5, all the way up there. Okay. So obviously we don't want to keep going. It's going to keep going bigger and bigger. So let's try -1. So if we did -1, that's going to be +2, but then -8. So 2 minus 8 is -6, plus 5 is -1. So at -1, it's going to be down here at -1. Okay, let's see. So then at 2, at -2, it's going to be +8. I'm going to write this down. +8 minus 16 plus 5. So that looks to be -3. So -2, -3. -3 is positive 18 minus 24 plus 5. So let's see. What's 18 minus 24 is -6. Plus 5 is -1. So it's back up at -1. I did that wrong. Back up at -1. Okay. What about -4? Maybe one more just to see. So if we did -4, that's going to be -4 squared is 16 times 2, which is 32. And then plus 8 times -4, which is -32, plus 5. So that would show us that would be right there. And that sure looks like a parabola, doesn't it? We can show it perfect. There we go. We can see that parabola perfectly goes through those points. So that's our parabola. They wanted us to say the vertex. We can see now that the vertex is -2, -3. And we can see that the axis of symmetry is right here at x equals -2. Of course, those two numbers will always be the same. So that's our parabola. Now, how can we get that quicker? Because we don't want to have to sit here and plot points every single time. Well, one formula that we can know, let's change colors so it sticks out, is that the vertex, the x-coordinate of the vertex, is always x equals -b over 2a. Now, why is that the case? That takes a lot of work, actually, to show why that's the case. So, if we have just a general quadratic equation, call it a x squared plus bx plus c, right? And we want to find the x-intercepts. So that's why I said that equal to 0. This is our quadratic equation. We want to find the x-intercepts. So we set the y equal to 0. So what are the x-intercepts? Well, just in general, we can use the quadratic equation, right? So -b plus or minus the square root of b squared minus 4ac all over 2a. So now, what is it though? So these are the different x-intercepts, the plus and the minus version. So the whole idea is that would be how we find these x-intercepts here. And then since a parabola is symmetric, we always know that the x-intercept is in the middle of those. So how do you find the middle of something? You average them. So what we're going to do with these is we're going to take the two solutions, -b plus the square root of b squared minus 4ac over 2a, and we're going to add them together. So plus -b minus the square root of b squared minus 4ac over 2a. And the whole idea is when we add these two things together, these are going to cancel out because one's plus and one's minus. So we end up with negative 2b, because you see we have two of them, over 2a. And then if we want to find the average, that's the sum of the solutions. So if we find the average, we multiply it by a half. So one of those twos is canceling. And so you see that the average of the x-intercepts, which is the x-coordinate of the vertex, is negative b over 2a. And so with that knowledge, we could have said, well, b is 8 and a is 2. So the x-coordinate of the vertex is negative 8 over 4, which is negative 2. And then we would plug that into the equation and say that when x is negative 2, we already did that, but we deleted it. So we'd say f of negative 2, and then we would just plug that in and say that that was the 8 minus 16 plus 5, and we got negative 3. So that would tell us that the x-coordinate of our vertex was negative 2. The y-coordinate of the vertex is negative 3. So that's a really useful formula to know. So you can find the vertex of the equations really quickly. So on to the next problem. Without graphing, see, there we go. Without graphing, locate the vertex. So we'll use what we just said. Negative b over 2a. So in this case, negative 6 over negative 3 times 2, which is just 1. So the x-coordinate of the vertex is 1. We'd say the line of symmetry is x equals 1. And now we just need to find f of 1 to find the y-coordinate of the vertex. So what is that going to be? Negative 3 plus 6 is positive 3 plus 1 is positive 4. So the vertex is 1, 4. Does it open up or down? Well, that would be based on if the whole thing is negative or not. So when I say the whole thing, I mean the biggest power of x, the most important power of x, is negative, which would mean that the whole thing is opening down. So let's take a look at this on Desmos. We should see something like that, where that vertex is the point 1, 4 that we calculated. So that's all from the previous videos. So let's graph negative 3x squared plus 6x plus 1. And then go back to home. And there we go. You see we have our upside down parabola with the vertex at 1, negative 4. Okay, what's next? Use the information from example 2 and locate the intercepts of the graph. Okay, we've talked about this so many times. You always find the x-intercepts and y-intercepts the same way. To find the x-intercepts, you set the whole equation equal to 0. So negative 3x squared. And when I say whole equation, I mean the y value, because remember f of x is the y value. So we're setting that equal to 0. And then we would factor it if we could, but it doesn't look like we're going to be able to factor this. So then we would use the quadratic formula, which is fine. So what is that then? Negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, that's fine. So let's simplify it. Go 1 plus or minus, what is that? Root 48. Over 6. Over negative 6. So what's root 48? How can you simplify that? Well, you can pull out a 4. 4 and 12, so you can pull out a 16. So 4 root 3. 1 plus or minus negative 4 root 3 over 6. So these will cancel and be 2 root 3. I mean, those are the x-intercepts. I guess we can go back to Desmos and confirm that. So we have 1 plus 2 root 3 over 3 is 2.15. Is that 2.15? Yes. And then minus. Negative 0.15. Is this negative 0.15? Yes. So those are the x-intercepts. And then the y-intercept is actually always the simpler one, when it's written like this at least, because you're plugging in x equals 0. You're making x equal to 0, and you see that y is going to be 1. And you do see that that is what you see right there. Okay, so now the domain and range. So we can see it easily from the graph. So remember what those are. The domain is all of the x values. So what are the legal x values you could put into this equation? Well, any of them, right? There's nothing restricting your x values. The domain of any polynomial is all real numbers. But now the y values, there are some restrictions on, right? Because we just saw, or we can think about what the graph looks like. Even just from our sketch right here, we can see what the range is going to be, what the possible y values are going to be. Because it never goes up higher than this. It turns around right here and never comes back. It's a parabola. So what's the highest it goes? The highest it reaches is this positive 4 here. So the range for this equation can go down all the way to negative infinity, but the highest it goes up to is 4, and it will be a bracket there because it will hit 4 at the vertex. So similarly, where is it increasing and decreasing? Well, again, picture what the graph looks like. So when we talk about where it's increasing or decreasing, you're talking about the x values, first off. Whenever you're talking about different places on the graph, you're always talking about the x values. So it starts off increasing, right? It's like we always say, left to right, it starts off going up. So it's increasing from negative infinity to x equals 1. They're not asking about the y values here. They're just asking, when they say where, they're asking about the x values. And then it starts decreasing from 1 to infinity. And notice how I'm putting a parenthesis on the 1, just because at 1 it's flat, right? It's not increasing or decreasing at 1. But there we go. We're just kind of building a picture of this parabola. Even if we hadn't seen it, we've got a really good picture of all the important parts of it now. So let's see. Here they're doing it again. Basically asking all the same questions. So graph this by determining whether the graph opens up or down. Okay, well, for that, we look at this, and that's positive. So that means it opens up. And by finding its vertex, okay, we'll do the same thing. So negative b over 2a. In this case, a is 1. So it'll be negative 6, positive 6, over 2. So the x-coordinate of the vertex is 3. And if we plug in 3, we get 9 minus 18 plus 9. We get 0. So that's actually the x-intercept as well, is 3, 0. So that also tells us that it has an axis of symmetry of x equals 3. And then it says the y-intercept. The y-intercept, so when x equals 0, that means the y-intercept is 9, 0, 9. That'll be on the graph. And the x-intercepts, which we already found, there's actually only one of them. So if there's only one x-intercept, first off, think about what that's going to mean. Well, that we didn't find the x-intercept. We found the vertex. So to find the x-intercept, it's just going to be the same thing. But you can think about, if you think about what a parabola looks like, if the vertex is an x-intercept, well, it can't have another x-intercept. But we can see by just doing our normal thing to solve for the x-intercepts, set the y value equal to 0. When we factor this, it's x minus 3 squared. And that's why it ends up with only one solution at x equals 3, which we see right here. Yeah, so let's go ahead and graph it. We've got everything important about it now. So we found at 0, 9, it's got a y-intercept. I think that's right there. And at 3, 0, it's got its x-intercept, which is also its vertex. And since we know that that's the axis of symmetry, we should also know that we have another point right there. And that's going to be the graph of it. So then the other question is just the domain. Like we said last time, the domain is all real numbers. The domain can be anything. The range, the possible y values. Well, look, this time there's a cap on how low it goes, right? Because it's opening upwards. So the range is anything starting at 0 up to infinity. Remember, the range is talking about the possible y values. And now when we talk about where it's increasing or decreasing, there we're talking about the x values. So it's decreasing from x equals negative infinity to x equals 3. And then it's increasing from x equals 3 to x equals positive infinity. Yeah. All right, I think we just got to do that 3 more times. So yeah, this is the exact same thing. So we first find whether it opens up or down. It opens up because it's positive. We do the vertex, negative b over 2a. So 2 times 2. So negative 1/4. So that's the x coordinate at negative 1/4. We'll go ahead and plug that in. Just be very careful. So negative, well, positive because it's squared. So 2/16 minus 1/4 plus 1. Okay? So we can't just multiply because it would change the answer. We've got to find a common denominator, actually, of 8, it would seem, since we can simplify that. So we'll multiply it by 2, so 1 minus 2, and then we'll multiply by 8 plus 8. All that will be over 8. So what is that? 9/8? 9/8. So when we go to Desmos, what should that be? 1.125 and negative 0.25, just because it'll show it in decimals. So that's our vertex. And then we just need real quick our x-intercepts and our y-intercepts. So easiest is the y-intercept. The y-intercept is going to be 1. As you plug in x equals 0, you get 1. 0, 1. The x-intercept, let's see. So we got to go 0 equals 2x squared plus x plus 1. Can we factor? No. Quadratic formula. Negative 1/2. Well, no, not negative 1/2. Negative 1 plus or minus the square root of 1 minus 4. So look at that. We're getting a negative inside of, it's not 4, it's 8. It's even worse. We're getting a negative inside of the square root, right? Because that'll get us negative 7. So that's an imaginary answer. So we get like imaginary numbers for our x-intercepts. But since imaginary numbers aren't shown on the graph, that means there's none. That means there's none. There's no x-intercepts for this graph. Which makes sense, right? Doesn't make sense? Because if it's opening up, and we see we have our vertex is already positive, so if we just sketch this graph out, it's going to be like our vertex is here, and it's opening up. So that totally makes sense that there's no x-intercepts. So because of all the fractions, that'll just be our rough sketch right there of it. We'll go to Desmos for the perfect thing. So then they want the domain and the range. So the domain, again, always all real numbers. The range, just what's the lowest the y value goes to. So that's right here. So the range is going to be anything from 9/8 up to infinity. As it goes up, parabola opens up. And then increasing or decreasing, same as before. It starts off decreasing this time. It's decreasing from negative infinity until x equals negative 1/4, because up until the vertex, right? But then it starts increasing, and it increases from negative 1/4 up to positive infinity. So there we go. Just thinking about parabolas, thinking about the different parts that they look like, increasing, decreasing, vertex. That's pretty much what makes up a parabola. So let's graph this one. We got 2x squared plus x plus 1. And there we go. Just like we said, no x-intercepts. We look at the vertex, just like we said for the decimals. Ooh, no, we got something wrong, right? We did some math wrong. Let's look at this again. That should be 9 minus 2. Yeah, that should be 7, not 8. Okay, that's not that big a deal. So what does that change? That changes the range, because the range actually starts at 7/8, not 9/8. And 7/8 is indeed that decimal that we were looking at right there. 0.875. 7 divided by 8. So now 64 is 0.875. So there we go. And we got our y-intercept of 1, and we see how there are no x-intercepts. Beautiful. So now we start writing equations. So let's see what we can do based off what we've talked about already. So determine the quadratic function whose vertex is 1, -5, and whose y-intercept is -3. Okay, well, y-intercept of -3, that definitely helps, right? So we know that our equation looks something like this. We'll start off, this is our quadratic equation, just a base quadratic equation. We just got to find the numbers to put in. But if we know that the y-intercept is -3, we know that's this number, right? So we know we have something like this, -3. And then what else do we know? Think about what we said about the vertex. -b over 2a gets you the x coordinate of the vertex. So we can just write that because we're using b and a. So negative b over 2a equals 1. Or in other words, cross multiply negative b equals 2a. Okay. So what I would do from this is now I would say we can do one more thing. We have a point here that we can plug in. We know that when we plug in 1 for x, we have to get negative 5 for y. So we can do that down here, and that'll get us another equation with a and b. And then we can do system of equation type things. So it's actually really nice because we're plugging in 1 for x, so that's just a plus b. And then minus 3. So now if we add 3 to both sides, a plus b is negative 2. So now it's just up to you how you'd want to do it. I actually do want to add them because the way I'm seeing right now with this negative b and this b, so if I add both equations, and just be careful with it, you end up getting a equals 2a minus 2, right? So now subtract a, add 2. You should get that a equals 2. And now if we know that a equals 2, and that 2 plus b is negative 2, we know that b has to be negative 4. And we should be able to test this up here, that if we do negative 4 equals 2 times 2, we do get 4 equals 4. So those a and b values satisfy both of the things we need them to. That we do indeed get that x coordinate of the vertex, and that this point is indeed on the graph. So now we have everything we need. Our equation is y equals, a is 2, so 2x squared, b is 4, negative 4, minus 4x, and minus 3, minus that y-intercept. So let's actually graph it on Desmos. Always good to check your answers, see what's happening here on the actual graph. So 2x squared minus 4x minus 3. So there's the parabola they're talking about. So what was it? Vertex at 1, negative 5. It does indeed have a vertex at 1, negative 5. And it does indeed have a y-intercept of negative 3. And that's what they asked for. Very cool, very cool. So it's the same idea as just going backwards. All right, determine whether the quadratic function has a maximum or minimum value. Okay. Well, so think about everything we've done with parabolas. What do they look like? This one in particular opens up, so it looks like this, right? So does this parabola have a minimum or a maximum? Well, look at it. It's right there. It's the minimum. The vertex is going to be the minimum of a parabola. If it opens up, if it opens down, the vertex will be the maximum, right? And that just makes sense. So let's find it. So we'll do the same thing we've been doing. The vertex is negative b over 2a. So in this case, negative 4 over 2 times 1. So the x-coordinate of the vertex is 2. So that's where the function has a minimum. Then the actual minimum value is whatever we get when we plug into f of 2. So we get 4 minus 8 minus 5, which is negative 1 minus 8, so negative 9. So that's the lowest value. That's the minimum value of this parabola. It looks something like this when x is 2. The y value is down here at negative 9. Let's go ahead and graph it to confirm. X squared minus 4x minus 5 does indeed have a minimum value there, and it is indeed at negative 9. So there we go. That's kind of a little introduction to parabolas. I think we're going to get just to some word problems next, actually. And maybe that's the end of chapter 4. Little with inequalities, little word problems. But that'll be fun. Come back for that. So if you learned something, definitely like, definitely subscribe. Definitely find my Discord and everything. And come back for more when I see ya.